Hi! In this video, we will have some sort of review on vector addition. Take note that the difference between scalar and vector quantities is that when we say scalar, it is a quantity that can only be described by magnitude, meaning to say value and unit. And these are the examples for that one. On the other hand, when we say vector quantity, it describes the quantity by both magnitude and direction. You'll have value, unit, and then direction. And then the examples for that one are the following. Take note that in adding vectors, the vector sum of two or more vectors is called resultant vector. Kung mag-add of two or more vectors, ang tawag sa resulta nga vector kay resultant vector. And at the same time, mailhan mo siya nga resultant vector, kinasi katagbo nga isa ka vector. And mailhan po mo siya nga addends or gipang-add nga vector kay gisumpay-sumpay siya. For example, for this figure, you'll have A plus B. So these are the addends. And also, resultant kay na ay kamit nga one vector. Again, take note, adding vectors is not the same or as easy as adding scalars. Sa scalars, all you have to remember is dapat same sila og unit. But then for kung mag-add og vectors, kinahanglang i-remember ang direction sa imuhang vectors. So here, napoy property imong vector addition. One is what we call as commutative property. Meaning to say, changing the position sa imong addends, dili mag-change ang result. Same lang gyapon. Ikaduha is associative. Regrouping your vectors does not change the result. And lastly, this equation here can be written as of this form. So again, there are two ways to find your resultant vector. One is through graphical method, and the other one is component or algebraic method. Their graphical method is subdivided into two. This is what we call as Polygon and Parallelogram method. So when we say Polygon method, for example, I have here vectors A and B to be added, and I'm asked to find its resultant vector. So first things first is that, yes, you'll graph the vector with its proper magnitude or iyang length and then even the direction. And then next, at the tip of your A, okay, mura ka mag-create og arbitrary origin, and then dira mo i-graph ang B vector. So meaning to say, at the tip of A, connected ang tail pud sa B. And then your resultant vector will be from the origin or tail, from the tail of A to the tip of B. That would be your resultant vector, A plus B vector. On the other hand, for parallelogram method, this is applicable for two vectors lang. Na siya limitation. Okay, when we say parallelogram, it's a four-sided polygon. So here, the only thing that is different from this one, differs from polygon, is that all vector starts at one common origin. Okay, so you'll graph A vector here and then even for B vector. So next, ang i-connect sa A vector is a line parallel to your B vector. Same as true for B, you'll connect a line parallel to your A vector. So you'll have here. Okay, I forgot to use broken lines for this one. So here, in order to locate your resultant vector is that it starts here at one common origin and ends to the intersecting point sa imuhang gi-connect nga lines. Okay, so that would be your resultant vector. Again, I repeat, this method is applicable only for two vectors now. In adding more than two vectors, still we're going to use polygon method. So again, I repeat, for example, I have here four vectors to be added. So all you have to do is to connect all of the vectors. And then at the same time, you resultant vector is from the origin to the endpoint where the last vector stops or ends. So here again, I repeat, our vector, our resultant vector kay daghang denotation. You can use any alphabet or letter. You can also use Greek letter. So here, take note that pwede ma-rearrange nimo ang imong gipang-add. Since, as I've mentioned a while ago, your vector addition has a property of what we call as commutative. So meaning to say, if I'll add first D and then pa-reversed, so I'll still get the same answer. So you'll have C plus B plus A vector. Still, you'll get the same magnitude at the same time, same direction for your resultant. For vector subtraction, so here again, this is the third property that I've shown you a while ago, that this equation can be written as of this form. So take note that how am I going to subtract the vectors? The negative signs of vector would only mean opposite directions. Again, I repeat, the negative sign here beside the vectors would only mean 180 degrees or opposite directions of vector. So for example, I have here A plus B vector and then this is the resultant vector. So how am I going to look for your A minus B vector, for example? So all you have to do is simply, you'll have to find the negative B vector for this one. So all you have to do, you'll have same magnitude, but then opposite in direction. So this would be your negative B. So in order to find your A minus B, all you have to do is simply A plus quantity negative B vector. That would be your graph for your A minus B vector. And the next, for the algebraic or component method, here your vectors can also be described in terms of, again, I repeat, number, units, and direction. So for example, I have here a vector with magnitude 1.5 meters, and its direction is simply at 25 degrees. So here, when we say component method, you have to look for its x and y components, and if possible, there's a 3 dimensions and z components. So here, again, I repeat as what has been discussed in the previous videos, is that here, if I have here an A vector lying along the first quadrant, so all you have to do is to, yes, look for its components. Again, I repeat, all you have to do is simply, ang pinakasimplest nga way is i-enclose nimo into a right triangle imong angle theta. So, in order to look for your AX and AY is that you use trigonometric functions. So, katoa. Okay, so if you'll notice here, again, I have a simple mnemonics here when looking for its components. Easiest way is to use sine and cosine functions. So here it's on the adjacent side. Your AX is on the adjacent side of angle theta. So pasabot kay cosine. So you'll have A cosine theta. Or ang process ka, you'll have cosine theta ka, adjacent side over the height, and then cross multiply this one. So you'll have AX is equal to A cosine theta. While your AY, if you'll notice, it's on the opposite side of your angle theta, so sine. So you'll have sine theta is equal to opposite, that would be your AY, divided by its hypotenuse. So you'll have AY sine theta. So here, another example of finding the x and y components of a vector in such a way that the only thing that is given is the magnitude of the vector and then at the same time its direction. So take note, one way to find is to enclose this angle alpha into a right triangle. Okay, so may bawaan mo siya nga AY because it's a vertical component or along Y. May bawaan pa mo siya nga AX kay horizontal nga component. So if you'll notice, your AX is on the opposite side of your angle alpha. So meaning to say your AX component is simply equal to A sine alpha. So, okay, we don't have to write this one. It's too, I'm too tedious or it's too kapway to write this one. So we'll just have to automatically write this as of this form. Next, your AY, if you'll notice, it's on the adjacent side of your angle alpha, so ka. So that means to say your AY is simply equal to A cosine alpha. Okay, here let's try to apply the things that we've learned earlier. And then in such a way that it has numerical values. So here find the x and y components of the z vector having a magnitude of 10 newtons and a direction of 30 degrees. So here, how to deal with the problem, how to attack here is that look at the angle. Okay, it's on the third quadrant. Take note. So the components must be both zx and zy must be negative. So here, inyong unang buhaton is to, yes, make a right triangle. Enclose this angle into a triangle, into a right triangle. So this is horizontal, so meaning to say this is your zx. Okay, so again, this will be your zx. And then the vertical one, kini, vertically downward, this is your zy, right? So let's label these things. So you'll have here rather red one. Let's try to label these things. So you'll have zx, and then the other one is zy. Okay. So here. So the trigonometric functions that we'll be using is these two. So, and then ka. Okay, so if you'll notice, look at your zx. It's on the opposite side of your angle alpha. So you're going to use side. So you'll have zx is equal to z sine 30 degrees. Okay, so here you'll have, take note that I forgot, your zx points towards negative x direction, so you'll have negative sine. Okay, so you'll have negative 10 newtons sine 30 degrees. And take note your calculators must be set in degrees for this case. So the answer is negative 5 newtons. I hat. Okay, the unit vector along x. That would be your zx. Or can be written as of this form also. You'll have 5 newtons. Okay, you may incorporate the negative sign here. Negative I hat. Okay, so kindly check the video that we've uploaded a while, few weeks ago. That would be your zx component. Next, for your zy. Okay, for your zy, all you have to do is that evaluate your zy. It's on the adjacent side of your angle 30. Adjacent side. So adjacent side meaning to say cosine. So you'll have negative, right? Cosine, z cosine 30. Why negative? It's because your zy vector is towards negative y direction or downward. So, and tendency, that would be negative 10 newtons cosine 30 degrees. So the answer would be negative 8.7 newtons. Okay, J hot. Or can also be written as of this form as 8.7 newtons, and then you'll have negative J hot. So that would be its x and y components. So here, take note that there are ways, again, as a review, there are many ways in order to write your vectors. It could be written as of this form. You'll have z vector, and then you'll have 10 newtons, the magnitude, and then the direction, 30 degrees west of south. I'll be teaching this later. Or can also be equal or can be written also in terms of unit vectors. You'll have 5 newtons negative I hat plus 8.7 newtons negative J hat. Okay, so this vector here can also be written in this form. And take note, you can't add this 2. This 2 has different unit vectors. This is negative I, this is J hat, negative J hat. The components of a vector can be positive or negative depending on where the vector is located on the xy plane and will have same units as the original vector. So for example, you'll have take note as a review from your mathematics, you'll have first, second, third quadrant. So if your vector is lying along the first quadrant, then both of the components are positive. On the second quadrant, you'll have negative ax and positive ay. If it's lying along the third quadrant, well, both of the components are negative. And if it's on the fourth quadrant, you'll have positive ax and then you'll have negative ay. If it's lying along positive x or positive y-axis and etc. So for example, if you'll have here lying along positive x-axis, so obviously that would be your ax has the same value as the magnitude and your ay is simply equal to 0. If it's lying along the negative x-axis, so of course your ax would be negative value of your magnitude. And then you'll have 0 nga ay. If it's lying along y-axis, so your ax is simply equal to 0, while your ay is simply equal to its magnitude positive since it's lying along positive y direction. And on the other hand, lastly, if it's lying along negative y-axis, so you'll have your ay is simply negative times the magnitude of the vector, and your ax is simply equal to 0. So here, what if the components are given and you're to find the magnitude and direction of a vector? So pabaliktad. So again, I repeat, the components are given and you're to find the magnitude and direction. So one thing is to use Pythagorean theorem for its magnitude here and to use tangent function for its direction or the TOA. And where should your theta be appropriately placed in the Cartesian xy plane? Okay, for example, here, take note that this is your north, south, west, voila, take note, and then east. So what if your vector is lying here? So how are you going to read this direction theta here? You cannot say northeast. You cannot simply say northeast, Dari. So take note of the mnemonics. You'll have end of start. So the vector or the angle starts from east going north. So this would be north of east. Okay, take note. What if here? Yes, it's from west going south. Starts at west going south. So that would be south of west. Right? Okay. Again, hinayon na to ha. Another example. Okay, you'll have here, it's from west going north. That's not west of north, but rather it's north of west. Okay, so again, take note of the mnemonics. So mag-start na siya always gikan sa major nga directions, kaning upat. So if you'll notice, look at the arrow, going here and then going there and there. So what if here? Kini. It's from east going south. So that would be south of east. Okay. Next. Okay, this would be, it's from north going east. So east of north. How about this one? Okay, it's from north going west. So west of north. And then this one, it's from south going west. So that means to say west of south. And lastly, it's from south going east, so east of south. And what are the directions? What if northeast, southwest, and blah, blah, blah. So that is simply 45 degrees. Halfway. Si 45 rin na nag-iyaan ng northwest, southwest, and southeast nga directions. That would be the end of our review on vector addition. See you in the next videos for more examples.